All right, this is Mr. Jern, and right now I'm going to show you how to solve some problems involving horizontally launched projectiles. Horizontally launched means that it's not fired at an angle, it is fired completely horizontal. So in other words, the initial velocity in the y direction will be 0. Couple of things when we're dealing with horizontal projectiles. There's a couple like general steps you could follow. Now these are just my steps, they're not anything written in stone or anything. But what I like to do is first draw a picture. So we have a window, we have a building, and we have a ball being thrown out, okay, at a certain speed, initial velocity in the x direction. It is gonna fall and eventually it's gonna hit the ground. We know that the height is gonna be our dy, our displacement that is going to fall, and we would like to know how far from the building is it going to land. That will be our dx, and that's going to be our unknown. Okay, so this kind of just gives you a little picture about what's going on, and it's just always a good thing to visualize. Second, we're going to list all the variables. We're going to indicate direction of any vectors we have. We're going to have a few. We're going to indicate if they are x or y variables. And we need to do that because we never want to mix x and y variables in equations, at least during doing these problems. So I'm just going to go through and list all of them. I'm going to start with x. It doesn't really matter. What is the displacement in the x direction? Well, that's our question mark, right? What is our velocity, our initial velocity in the x direction? Well, let's see, 15 meters per second. It's moving to the right, so we'll keep it as positive. And our acceleration in the x direction, well, there's no air resistance or anything like that, so the acceleration is going to be 0 meters per second squared. Then let's talk about our displacement in the, it's supposed to be a y, so try that again, the y direction. So how far does it fall? And its displacement. So the ball is starting at the top and it is falling downward. So that is our displacement. It turns out the window is 15 meters high, and so the ball is going to fall from there. It's going to fall to the ground, meaning we're going to have a negative displacement. Velocity, our initial velocity in the y direction is, well, 0, because it is, that's the point of a horizontal, that's why this is a horizontally launched projectile. And our acceleration in the y direction is negative 9.8 meters per second squared. Okay, it's gravity. All right, that's our step number 2. Find time using variables from one dimension. Okay, so we have available to us several equations we can use, and we want to use one of them or more, probably just one, to find time. Typically, well, depends on what you have. It says in my step 3, using variables from one dimension. So what you're going to do is look at the variables that you have, and you have to decide which of these gives you enough information to find time. Is it going to be just the x's, or is it going to be the y's? Well, essentially, basically, we can't, we're going to end up having to use, we don't have enough information from, oh, that actually should be one of our variables. Time is our question mark. Sorry, I should have written that here. So we don't have enough information from our x variables to solve for time, looking at the equations. But we do seem to have enough variables with our y. We have enough variables in the y direction to solve for time. We have dy, we have viy, and we have ay. So we have all of them, essentially. We seem to be missing one in the x. That's why we can't use that one. So we're going to find time using that. So which equation should we use? Well, we look at this, and typically when you have, there's several we can use. We're probably pretty much going to ignore this one because this is average velocity. We don't have average velocity, especially in the y direction. We could probably calculate it if we knew some more things. VF finds time, where we don't know VF, so we can't use that to find time. And by VF, I don't mean after it crashed, because that'd be 0. I'm talking about while it is a projectile and it's still in the air. We could use this one. In fact, we probably should, because we have another one that involves time, but it's got a final velocity. We don't know that. Again, another one that has final velocity. So we're going to end up using this one, but this one's already kind of rearranged for us down here, because if VI wasn't 0, then it would involve, we wouldn't be able to solve for time very easily. We'd have a couple different times maybe. And so we're going to use this one. VI is 0. Okay, VIY is 0. So we're going to use this equation. So let me just write that down. Time is equal to the square root of 2 times the displacement in the y direction divided by the acceleration in the y direction. We got to be careful to make sure we write that so we don't ever mix x and y. Okay, they're at right angles to each other, and so they won't interact. Find the time using the variables from dimension. Okay, let's do that. So I'm going to plug this in. Time is equal to 2 times the displacement in the y direction, so negative 15 meters, divided by the acceleration in the y direction, negative 9.8 meters per second squared. So time, when we plug that into our calculator, is 1.749. So let's say 1.75 seconds. 1.75 seconds. And it's seconds because once you wow, can't talk. The meters are going to cancel out, and then the seconds squared will get unsquared due to the square root. So I'm just going to put a little circle around that. That's not our final answer, but that's how long it's spent in the air. And that's kind of important to know. So let me just tidy things up a little bit here. So that's how long it's spent in the air. Now we found the time. Great. Time is not a vector, it's a scalar, and so it's basically not affected by dimension. You can mix that together with the x's. So that's what we're going to do. Use time to find the missing variable in the other dimension. And like it says here, time is a scalar, so it applies to all directions. So we want to now find, what are we trying to find? dx. Okay, we know vix, the initial velocity, and we know the acceleration is 0. We now know time. So let's take a look at our equations. There's several we can choose from. We can kind of finagle things and say, well, since there's no acceleration, we can use this equation because the average velocity is the initial velocity because it doesn't change. That would work, no problem. We can use that. We can use, we could possibly use that to, we're trying to find distance. No, we can't use that one. We can definitely use this one, or pretty much any of them now. So let's just pick one. I'm going to choose, just for fun, I'm going to switch colors here. I'm going to choose distance in the x direction, displacement in the x direction is equal to 1/2 ax times time squared plus vix times time. Okay, I'm going to substitute. Dx is equal to 1/2 times 0 times time squared plus, now I look back at my earlier thing, vix is 15 meters per second times the time I just calculated, 1.75 seconds. This part goes away because it's multiplying by 0. And when I multiply these together, the 15 meters per second times seconds, the seconds are going to cancel out. And if I put that in my calculator, I get 26.2 meters. So that is how far the ball will go in 1.75 seconds. Or when we found that out, because we were able to use these variables to figure out time. So just follow those steps and you'll be fine.